I'm going to be presenting question 6 from the 2019 AP Chem test. So, nitrogen dioxide, NO2, is produced as a byproduct of the combustion of fossil fuels in internal combustion engines. At elevated temperatures, NO2 decomposes according to the equation below. So we have 2NO2 turns into 2NO plus O2. The concentration of a sample of NO2 is monitored as it decomposes and is recorded on the graph directly below. The two graphs that follow it are derived from the original data. A. Explain how the graphs indicate that the reaction is second order. So, when you're dealing with graphs in order, you want to look at which of them is linear. And if we look at these three graphs, we can see that 1 over NO2 is linear, which means that the reaction is second order. And if these two were linear, then the reaction would be 0 order for this one and first order for this one. So, you can write that. Okay. B. Write the rate law for the decomposition of NO2. So, since we know that it's second order, we can write that. Simple. And for both of these parts, it's 1 point for writing the correct answer. Okay. C. Consider two possible mechanisms for the decomposition reaction. Part I. Is the rate law described by mechanism 1 shown below consistent with the rate law you wrote in part B? Justify your answer. So, if we look here, we have step 1, slow, and step 2, fast. When you're dealing with multiple steps in rate laws, you'll always look at the slow reaction first. So, if we look here, NO2 plus NO2 becomes NO plus NO3. When writing rate law for this, we just look at the reactants and multiply their concentrations by the rate constant. So, if we write out the rate law, is that, which is exactly the same as what we wrote in part B. So, you can write that. And then for part 2, is the rate law described by mechanism 2 shown below consistent with the rate law you wrote in part B? Justify your answer. Again. So, step 1, fast equilibrium. Step 2, slow. Now, step 2 is slow, so we look at that. And the rate law would be rate equals rate constant times the concentration of N2O4, since that's the reactant in this step. But if we look at the reaction as a whole, we see that it's actually an intermediate, so it can't be used in the final rate law. But if we look here, we see that step 1 is in equilibrium. So we can write the equilibrium constant is equal to concentration of N2O4 over the concentration of NO2 squared. And we can rewrite that as that. And we can substitute this into here to get so for our justification, we can write